Well, we have, apparently we have 45 minutes. Apparently. But if I won't look at my watch, then you'll forgive me. If you promise not to look at your watches. This is a Birds of a Feather session. I'm Mike Keith. Now, Birds of a Feather is supposed to be more informal, more casual, more conversational. So I'll ask questions. You guys answer. You guys ask questions. I'll pretend or do my best to answer. But hopefully you won't feel uncomfortable making comments or questions along the way. As I say, the casual part of this is what makes, I think, beneficial to all of us. Unfortunately, the 45-minute time limit is a little bit hard. So what I've done is I've tried to separate it into different sections. And based on your feedback and what you'd like to spend the time on, we'll kind of zero in on the parts that are most interesting to you and then go from there. So, remember, casual, informal, safe stuff. I thought about just like, how could I make people feel comfortable? And I thought, well, I could just come in my underwear, but I didn't think that would work very well. And I thought, well, maybe I could get them to go in their underwear, and I didn't want to do that either. So I just have to leave it up to you guys to feel kind of as comfortable as you can and open up the questions that you feel, or, nothing's too stupid to ask. I might answer stupidly, but that'll be my problem. So the first thing, also, how many people here were at Linda's session this morning, or this afternoon, or whatever? Linda DeMichel. She gave a JPA session. She talked a little bit. Hands up high if you were at that one. Okay, about a third of you. So Linda covered a few things a lot. Unfortunately, I didn't talk to her beforehand to kind of work out. Usually we do that and we kind of work out how things are going to go. We just never had a chance. So she talked about schema generation. I have a little bit about schema generation here. I could talk about some other things about schema gen if you like. We can hone in on that. She talked a little bit about converters, but I think there's a lot more that can be discussed about converters, and I think a lot more people here would be interested in the converting part. This is, for people who use Eclipse Link, there's a converter feature that's been kind of translated into the spec. Hibernate has a similar kind of feature called user types. For those of you who have used those and would like those to be standardized, at least that's the one that I've had the most feedback on over the years. So I thought we would start with that. Yeah? No? No, I don't see very many shakes of the head, so we'll go ahead with that. And then I'll carry on from there. Okay, so the provider looks for these classes that are implementing attribute converter, and this is what it uses to convert the type, the state, of the attribute of the entity type. The attributes themselves are essentially basic attributes. Now, basic is kind of a general term. It really just means anything that doesn't fall in some other category. It reverts to being a basic. And although we don't actually say so in the spec, what generally will happen is you go through this list of things that you try to do to the attribute, and at the end of it all, if you can't do anything else with it, if it's some other object that you don't know what to do with, and not a known type, then you can just serialize it out if the database type is appropriate. So this allows you to take a method and do that kind of serialization, if you like, or transformation or conversion on your own and map it. Now, I say that any basic type, strictly speaking, this means that it has to be an attribute of one of the standard JPA types, an entity, an embeddable, or a mapped superclass, right? If it's an attribute of one of those, then it should qualify for conversion. There's two ways you convert. You can opt in, say I want this attribute to be converted, or an auto apply, meaning that all the attributes of this given type are going to be converted using this converter. So it's kind of a catch-all. And you should be careful which one you use depending on the circumstances, obviously. Finally, a note. We disallowed various types of basic attributes to be converted. And just the ones on the bottom. IDs, I think it should be fairly obvious that IDs are kind of a very special type of attribute. They're used all over the place within the provider. They're keyed on. It probably wouldn't be a good idea to be converting a primary key. Secondly, a version, that is a container-managed attribute, not generally used by the application developer. It's sort of there that the developer declares, but really the container is managing it. So you don't have too much business in the way of playing with that, although it is possible. And sometimes people have thought, well, maybe this would be a way to implement some kind of optimistic locking policy, for example. And so that, it's not portable to do that. It might be allowed by certain providers, but we disallowed that in the spec. Enumerated, people, when they first read that, they say, oh, wait a second, that's a really, that's a common thing. I want to be able to convert an enumerated type. Now, that's not what this is saying. This is not saying that you can't convert enumerated types. This is saying that you can't convert attributes that are annotated with enumerated. Because if you're doing @enumerated, then you're performing something on that enumerated type already. You're specifying the strategy, for example, whether it's going to be an ordinal or string or whatever. And so you're kind of doing something already. If you're going to do conversion, then you don't need @enumerated. You can just convert the enumerated type yourself and don't use enumerated annotation, and it'll be okay. Same with temporal. You can convert a date, but don't annotate it with that temporal. And then relationships, obviously you're not going to convert related entities. Again, these are just attributes. So what do you do to convert? Well, you implement and you annotate. You implement this simple interface, which is called an attribute converter, under the JavaScript persistence package name. And there's two methods, convert to database column and convert to entity attribute. The convert to database column takes the attribute itself, which is of some type, and then converts it into returning the type that goes to the database, and the other method does the opposite. So these two methods, or the two types rather, are the types of the X and the Y being the entity attribute type and the database conversion type. So the bottom here has this converter, and this is what you do to the converter class. You annotate it. And you may or may not have this auto apply on it. Again, the auto apply says it's going to apply to every attribute of that type in an entity, a map superclass, or an embeddable class. So it's pretty heavyweight, and you would only want to do that in certain cases. So here's an opt-in. I have the auto apply in gray, so just ignore that for now. Assuming you didn't put auto apply on there, we have a Boolean to integer converter. We're going to define the two types. The Boolean is the type of my entity attribute, and the integer is the type that it's going to the database as. So I convert to the database column. I'm doing a Boolean.true equals just because this Boolean here may be null, right? Depending on what's in the entity attribute, maybe it never got set, so I have to consider that case. On the other hand, the other one going from the database column to the entity attribute is likely not going to be null because something in the JDBC will probably create some value for it. Now, the bullet or the bubble up above has a statement saying that this will apply to wrapper types as well. So defining a wrapper type here, primitive types as well. So defining a wrapper type here means that it'll also apply to primitive types. If I have a lowercase Boolean in my entity, and I have an auto apply here at the converter, then it will be a candidate for being converted and will automatically be converted by the provider. Okay. Any questions so far? Yes?
Is this all there is to it, or will I be able to get back to the Java attribute like the same converting option of key so that I can access generic parameters of my attribute?
This is all there is to it. You can access the attribute itself through this method. You define this class, so you could do anything you want within this class, but you only get access to the attribute itself. You don't get access to the instance.
Yeah, so only to the value.
Right. Yeah.
Okay.
Yeah.
Thanks.
Yeah. Any other questions? Yes. Question is, can they be chained to go through multiple converters? It's not currently defined that you could apply multiple converters. You would have to define a sort of single converter which called those other converters. currently. In fact, right now, if you had multiple converters on an auto apply, then it would be undefined which one actually gets invoked. Because if multiple converters have the same target type, how does it know which one? It won't just do all of it. It'll try to pick one and then be undefined. Any other questions? So on the application side, I use the convert annotation. So this is a kind of annotation that's meant to be used, well, it's multi-purpose really, but the primary use of it is that it's an opt-in mechanism to say, I want to convert this specific attribute. And the converter class will be used to say what converter class should convert this attribute. The attribute name is specifically used for when you have a map or when it's embeddable and you have to use a dot notation to get into which attribute within the embeddable you want to convert. And we'll show you an example of this in just a minute. And the disabled conversion is when you have an auto apply and you want to specifically subcase where this one isn't converted. So everything else is converted, but this one is turning off conversion. All right, so here's opting in and using the convert. I'm specifying the converter class, and this is the typical case where all you do is you specify the class. And here I have a column on there as well, and I've obviously forgotten the bracket. But the preferred status is going to be then converted using this Boolean to integer converter class. Funny story. I actually had these slides, and I didn't back them up a week ago, and I lost my hard drive. So you're seeing a second copy of these slides, which are only probably slightly resembling the first copy. There's stuff that's here that wasn't there, and stuff that's there that clearly isn't here. So you get what you get. Here's some examples of nested conversion. I've got an element collection, so I can convert a collection of things, a collection of basic. So I could have a collection of strings, just a list of strings, and then I would apply the convert annotation. It would convert each of them. In this case, I've got a map keyed by string with elements that are strings. And if I don't say what I'm converting, the default is just going to be the value. Okay, just like anything else. When you use annotations, the standard practice is that you're applying that to the value unless you say that you're doing it to the key. So here I'm saying I'm using a phone number converter class and I'm converting the values in this map. The second example here, or attribute, is an embedded attribute called account detail. And here I'm using the attribute name. I'm converting a URL, and it's the transaction history URL within account detail. Now, if I have nested embeddables, then again, I would use a dot notation. Okay, I would say, if I had, say, some other embeddable within account detail, like address of the account holder, I would say address.city, and then have some string converter applied to the city, for example. All right? Lastly, we have a relationship where we've got transactions stored, and they're keyed in this map by a basic object, a date. So I'm converting the date, and to indicate that, I'm using the attribute name of key. Okay, so this is dedicated name key. We've used this in other examples or in other cases in the JPA spec where you say key, and that indicates that you're talking about the key to be converted. Again, if I had an embeddable object that was the key, I would use a dot notation to indicate some specific attribute of that embeddable object. Any questions about these? No. Okay. Okay. So that seems to all work fine. However, some things you should be aware of when using a converter. Here we have a simple query that's looking for all the preferred customers. Well, we're converting preferred status. So the provider, knowing that it's being converted, has to then go ahead and convert the operand, the right-hand side of that expression. Okay, so I'm executing this query. What if I have this table? I've got some accounts, and I've got some stati, is that right? Or statuses, I don't know, that are sitting in this table. And let's say that One of them has, legacy-wise, has the status of 2 because, I don't know, there used to be a gold preferred status. But nowadays we just have preferred or not preferred. And then greater than 0 was our test, right? If I went back, we had our test, our conversion. If it was greater than 0 in the database, then it must have been true. So he's preferred. Well, what happens now? We have a fail. Our equality fail is not going to work. Why? Well, because we have a bunch of mappings of integers to Booleans. And we said, okay, all of these integers are going to map to anything above 0 is going to map to true. But going the other way, my converter says, oh, if it's true, I'm going to map it to 1. So when I map true, what's the SQL going to come out like? Select all the accounts where the preferred status is equal to 1. And I'm not going to get this poor gold preferred status. The guy who's the most preferred doesn't get selected. Isn't that bad? So we have to be careful when that's the only lesson of this. I'm not giving you this to show you how stupid I am. I'm just showing you that you can make mistakes. And if you're not aware of all that's happening here, in particular, you're not aware that the provider is going to be converting these values in your SQL, in your JPQL, that end up in SQL, then you could end up shooting yourself in the foot. All right. So that is converters. Anything about converters that you want to ask before we leave converters? Last chance? No, it's not really your last chance. You can ask me later. Oh, he doesn't trust me.
Sure. How would you work around that situation?
How would I work around the situation? Well, that is a good question. The way I would work around it in this particular situation is I would know that there would be 2 values potentially in the database that map to true. So in my converter function that said greater than 0 is true, I would know that a 1 maps to true or a 2 maps to true. Likewise, in my preferred status, I could do one of 2 things. I could say map another value. I could do a different conversion and say where preferred status is equal to this or that, and then can provide that in my conversion. In other words, if I had some value of 2, let's say I put 2 in here. So it's going to take this value automatically and put it through my conversion routine. My conversion routine can do whatever I want it to do because it's my routine. I'm defining it. So if I have 2, then I can put 2 in there and it's going to do a check for 2 as well. Or I can put a second clause on there and say where it's equal to this or it's going to be equal to that. So I could say true extra preferred or true preferred. You see what I mean? So because my conversion can handle it both ways, I could actually manage that, but I would have to still jigger with my JPQL. I'd have to add an extra clause to make that work, right? And I'd have to rely on the fact that the provider is not going to look to see, oh, you know what, this is really Boolean, so make sure that it's still the Boolean type and that it's not going to fail going through the conversion process before it even gets to square one. Any other questions? Yes.
I actually asked this in the mail list.
Can you speak up a little bit? I'm half deaf.
I actually asked this a few months ago in the mailing list. There is a limitation that I can see in the current design of converters. That is that there is no access to the actual target type for which the converter is being measured. And this limits examples like if I want to create a general enum converter, that is something that I have done a lot in the past, particularly to Hibernate for me. I still can't. I have to have one class for an enum because I don't know which specific enum is using that. For instance, we usually have annotations like acronyms that are supposed to be used for each constant, and this could be very generic if I actually knew for which specific type the converter is being used. But if I just have to extend them to have specific type, and then to be able to have this information available to my general converter.
Right. So if I could just rephrase that question. Okay, rephrase the comment. The comment is, tell me if I've got it wrong. What I'd like to have is a more abstracted type of converter that could say, I want to apply this converter to any type, and I can apply this type at runtime. Is that correct? So I can apply a conversion of, I can say, an X converter to Y converter, and I would know somehow in my X converter to Y converter, based on whatever type is X and Y, that I can do this conversion. So, for example, if you're a enumerated type, I'm having a enumerated type to integer. And you can accept any enumerated type, and you convert that to an integer. That's an abstraction over and above this. Right? You're sort of generalizing it. And so, I mean, to some extent, you can do that. You can have a superclass if there are subclasses. If there's a hierarchy there, you could do that.
So then you have to have one converter for each type in the hierarchy.
Well, that's no different from what you're doing, because you're going to have to have a case statement.
But you have to annotate it multiple times. You have to annotate each attribute. Yeah? If I have multiple converters for,
Yeah.
like for each enum, I have to do an annotation for each attribute instead of saying convert all.
No, I don't think there's any difference there, because you would still have to annotate each attribute anyway, or you're going to do an auto apply.
Yeah, exactly.
Yeah, but that's the same whether you do it abstractly or not. You have to either convert, or you do an auto apply. There's the two choices, and whether or not it's an abstract converter or not, I don't think that changes. But so my argument is that I'm not so sure that that's too useful. But that could just be me. Maybe it's really useful, and I haven't seen it yet. But if more of you feel that way, then let us know, and we can look at it. My feeling would be it would actually complexify it more than it'd be worth doing, I think. But
Can I ask a question as well?
oh yeah,
Just go to not reading the one before. The workaround you gave was in the code to say like I know one is a true boolean or and two is false. But if we assume it was legacy code, why don't we do the workaround in the database itself and say like everything above 0? So you define very well. Is there a specific reason why you gave the other one?
well, so I'm assuming you can't change legacy code. You're not going to change database code. DBAs don't like that much. I don't know how many of you guys had to work with DBAs. They have long white beards and they're really stubborn. But the JPQL code generally isn't going to be legacy. It's something you have more control over because you're writing it. That's why I say you can add a clause onto that one and have different values mapping to the same one. That was the only reason I gave that. Yeah.
Out of curiosity, if you did greater than or equal to true, would it blow up, or would it translate greater than equal to 1?
That depends on the provider. Again, I mean, even my fix depends on the provider. So maybe your fix is as good as or better than mine. I mean, we haven't defined exactly whether the provider has to type check that value against the original entity attribute. Okay, so if it doesn't, maybe that would work out better. I don't know. But there are going to be other problems that you could bump into in the same area. I just only gave this kind of funky example because, just so you knew. Now you'll never make this mistake, hopefully. All right, so, well, that was probably 25 minutes of converters, but worth it, right? What do we want to do next? There's query enhancements. There is, let's go back. Doggone it, these stupid bubbles. Oh, there we are. Stored procedures. Some of these query enhancements and stored procedures, well, they've been in the JPA 2.1 spec for the last year or so. I mean, they were introduced in JPA 2.1, and we haven't released since last Java 1 at least, so they're still there. But for those of you who haven't seen them, we can talk about that. The new thing, unsynchronized persistence contexts, is we've added since then. That's mildly interesting. Schema generation, Linda talked an awful lot about this morning. But again, that's kind of mildly interesting. I don't know. For my definition of interesting, it might be completely different from yours. Who's interested? Who wants to call it a day and go get coffee? I don't know. Okay, how many people vote for query enhancements? My goodness, we have a winner. I'm not even going to ask. I'm going to save the extra 30 seconds and go on to query enhancements. Darn these bubbles. Okay. There's 5 main query enhancements that I've picked out. There is actually more that we've added, but these are the kind of ones that I see as having some value, or the ones that I get asked for the most. Downcasting. Now JPQL queries are polymorphic already. They are. You'll get all the subclasses when you ask for a class. You'll get its subclasses as well. We introduced a type, is something of a particular type to kind of allow you to filter based on a subclass. But now with downcasting, this allows us to access the state of the subclass. All right, and you can do that both in the from or the where clause. So in the first example, I'm selecting the name and the ID from the customer, and I'm joining the customer account, treating it as a savings account. What that does is allow me then to access the balance of the savings account, assuming that balance wasn't also an account. I'm not sure why it wouldn't be, but let's just assume that this was a savings account specific state, and then I could access it within the where clause and do a filter on 500,000. Awesome. The second example says, well, now I'm going to select all the employees, but I want to select them based on different criteria. All the full-time employees, they have a salary. If their salary is greater than 50,000, I want them returned. But if they're a part-time employee, then they get a rate of pay, a pay rate. And they're getting $100 an hour. So all the employees that are either full-time or salary, full-time or part-time and getting a salary of 50,000 or a rate of 100 will get selected. You see that? See how that works? It's kind of useful sometimes. Any questions about that? All right. Let's just move on. Oh, all right, let's go back. What happens if there's a... If there's more than one type of account? Well, it'll only pick the savings accounts. Yeah. That's the idea of this one, is that you're only joining across the savings accounts.
Why don't you just directly join with the savings account?
Well, because this is a crappy example. That's why. I wanted to save space. But if you were me, you would have done that. Yeah, you would have done the smart thing. I didn't. Okay, any other questions after I've gone? All right, let's go on to outer joins with on. This doesn't do a whole lot other than just add a condition to the outer join. We already have outer joins, obviously, and what we can do is we can say on some other condition, and that will include that in the outer join. In other words, allowing it to be null in those cases. So that's different from the bottom one, where I'm including the amount is equal to 100, or balance is greater than 10,000, where it's part of the filter. It won't get included. So there's a difference between the top one and the bottom one. Including the condition in the on is including it in the outer join itself. In the bottom case, I'm actually filtering against it, so the regular filter rules apply. This doesn't happen very often. I'm not even sure why I put this in here. I regret it. Oh, question. That's why I put it in. The question is, can you do an or on the on condition? Well, no. Not in, no. Yeah, it wouldn't make sense. Any other questions? Okay, you know how in JPQL you can do select new, and then maybe you don't know that. You know that, by the way, in JPQL, you can select new, some type which is not an entity type, and then put a bracket, some fields, an end bracket, and it'll use the constructor of that class and create a new instance of that class based on the results from your query. For those of you who didn't know that. You probably already all knew that. And some of you may have also wished you could do that with native queries. How many people here wish they could have done that with native queries? I'm sure there's many more that aren't putting your hands up. That's why we added the feature. Because we knew inside yourselves you always wanted to do this. We've given you what you wanted exactly, even though you didn't know you wanted it. You can now have a native query that does a select, and in this case we have a result set mapping that is, how many people here use native queries at all? Wow, that's a lot. I think it's on the rise. It used to be, 3 or 4 years ago when I'd ask people, 1 or 2 people would put their hands up, and they did it embarrassingly, like. Now you guys are like with pride, right? No, it's on their eyes for sure. Well, here I'm specifying a result set mapping of customer detailed result, and so this makes it clear here. This result set mapping is using a new annotation called constructor result. And that just says, well, here's my target class, which is a generally non-entity class, but it can be an entity class as well. And by specifying an entity class, it will create an entity which is detached. And then it'll use these columns, which are the columns. Sorry, I just heard beeping. Did anybody else hear that beeping? It kind of makes me nervous. I'm Canadian. We don't have beeping going on around here in conference centers, but here I'm nervous, and I cross the security of the border, and I get nervous when I hear beeps. So here we have these column results that are specified in the order the constructor expects them. And that class, the customer details class, will have a constructor that accepts those 4 things, and it will be instantiated just as you expected them and always wanted them to be. Yeah?
The application deployed, does it check to see if that constructor actually exists, or does it just fail for syntax?
The question is, when the application is deployed, will it fail fast? Is that your question? And the answer is not typically, because at deployment time, there's not a lot of validation that will happen in these kinds of things. We don't define in the spec whether you have to or not. If it's it wouldn't be too hard to do, so it's possible that a provider might, but I wouldn't expect it to. Any other questions? Does it support nested constructors? No, it does not. No. How exactly would you want it to support nested constructors anyway? What would you expect it to do? Would you want to be able to put a constructor result inside this constructor result?
Yeah.
Is that how you'd want it to do? Okay, I'll wait and see if someone else asks me for it. See me in 5 years. No, I don't know. Maybe we'll get a flood, and I never heard of that.
So when would you need that kind of thing?
What, a nested constructor? Oh, this. That I can answer. The other one he'll have to answer. This is when you have a native query. So sometimes people want to return results that are not managed. They're just sort of a bunch of data, but they don't want a bunch of fields all as result set rows, the way you get from JDBC. They want to have structure to it. So they put them in non-entities that they're not saving or never being persisted. That's usually the case why you use the new in JPQL. So now we've just given parity to the native queries as well, where they also can have these constructor results of non-entity classes being created that contain a bunch of data. That's pretty much the case. Ah, good question. Yeah. No, you can't. I wish you could, though. The question is, can you have variable argument constructors? Variable argument constructors. So, dot, dot, dot. No. I don't think we've ever supported that in JPQL. But if we add it in JPQL, we'll probably add it here too. That's all I can say. Okay, let's move on. I'm answering too many no's. I got to move on. Okay, this was actually more common than you might think. People want to have named queries because named queries are cool. And like, it's really a lot nicer when you have a named query stashed away, right? It's been pre-compiled, it's ready to go, you just execute it. But the problem is, people didn't want to have to predefine these named queries. They didn't want to have an annotation with the query in it. They wanted to be able to create the named query, say initialization time or something, and then have it ready to go. And I want to do the same thing myself. So I certainly have sympathy for this. And so that's why we put it in. The idea here is that you create a query dynamically, and then you add it to your set of named queries that exist in your Entity Manager factory. And so the first thing is just creating a regular query. The second one is Entity Manager factory.add named query, and then you're adding it, and that gets put in your set of named queries that the Entity Manager factory keeps track of. And then I can use it anywhere else in code, just saying create named query, and I get my pre-compiled query, and I define my parameters and go. So it is really quite handy, I promise. Should be no questions about this because it's pretty straightforward. I'm not answering them anyway. Because this is cooler. Inline database functions. Now this is cool because it allows you to access the power of your database functions. That we don't have to define all the functions that exist in every database. Okay, we started down that road. We have a bunch of numeric functions. We have a bunch of string functions that we started adding to JPQL. But you get to a point where you don't want to do that anymore, right? Or specifically when there's functions available that aren't even there on most databases. They're only there for one or two databases or one specific database. And so by allowing you to plug into that function in JPQL directly, then this allows you to call that function but still use JPQL. Now this is cool, but it's also bad. Why do I have an uneasy feeling about this? Anybody want to tell me? The whole point of JPQL is you don't have to bind yourself to a database, right? And here, what have we done? We've allowed you to bind yourself to a database. So yeah, it's kind of greasy, but I know people ask for it, and they keep asking until they get it, so we finally give it. I know, just like Dad, just giving out allowance. But that's kind of, it's important for some people, and at least it's limited, right? You have functions that are there, and you could, right? You could actually, have some predefined function for a database, and you could move to another database, and if the function doesn't exist there, you could user define it and create it there, right? So sorta, if you look just the right way and squint. Store procedure queries. Well, we have 7 minutes. So what did we have left? We had unsynchronized persistence contexts, stored procedure queries, and schema generation. How many people here vote for stored procedure queries? Okay, how many people here vote for unsynchronized persistence contexts? How many for schema generation? Okay, schema generation's out. How many people vote for either of stored procedure queries or unsynchronized persistence context? Stored procedure queries. Unsync PCs? Oh, man. You're killing me. Okay. I really can't do both. I'll try to do both. Okay? Okay. I'll try to do both. Here's stored procedure queries. I'll show you an example. I create a stored procedure query like this. Add name stored procedure query. This is a static stored procedure query. So I have an annotation. Just like a named query, right? But it's named stored procedure query. I name it, and I have the procedure name. This is the database procedure name. And then I put the parameters, and they're specifically stored procedure parameters. I have to specify the name of the parameter, the mode. This is whether it's in, out, or in some databases, a ref cursor if I want to return a result set. And then I specify a result class if it's returning a result class. It may not be. It might just be returning a value or nothing, right? Just an update count. Depends on the stored procedure. How would I execute it? Well, I bind the parameters, and then I call one of these execute methods. Just use execute. It works all the time. And I say get result list to get a result list, or get single result to get a single result. I have to, once all the results are obtained, I get output parameter values for the out or in-out values. And it looks something like this. Create name stored procedure. I create it. This is the name of my stored procedure. I set the parameters of the inputs. If I have defaults, then I don't have to set the parameter if I don't want to. If the default value is good enough for me, I'll use it. And I execute it. I get the result list, and now after I get the result list, I've drained the results, then I can go get the output parameters and get those. Any questions? No. Moving on. Unsynchronized persistence contexts. Unsynchronized persistence contexts are good for one main thing. That is if you have some people would like to call it conversation, some people call it an application transaction. Really, it's essentially a bunch of operations that each involve a single transaction, but you want them all to be atomic in one logical transaction. It's not a real transaction, I call it a logical transaction because you want them to be atomic, to either occur together or not occur. So, if I want to do this right now, it's a little difficult. I can do it, but it's difficult. It involves having non-transactional calls and then creating other transactions and then creating different types of beans and so on. So this was the case that we were trying to solve. What you can do with this unsynchronized persistence context that doesn't automatically join the transaction is you can call all the regular things that you can do in a transaction, like persist or merge, remove, these sorts of things. These are regular transactional operations, but you're not got a transaction in progress. You just got a persistence context. So you're running around changing things in your persistence context, but it's never writing anything out to the database. It's just keeping them all stored up. Meanwhile, transactions are starting, they're being committed. They're starting being committed, and meanwhile, you're doing nothing. Your persistence context is just staying as it is. That's the idea of an unsynchronized persistence context. The key to the unsync PC is that you can cause it to be synchronized and be enlisted in the transaction anytime you want. All you have to do is call join transaction, and that will cause it to be synchronized with the current transaction. There must be a transaction in progress. Once you join it, it will get synchronized when that transaction commits, but only for the life of that transaction. Okay? Now an unsync PC can happen on different kinds of scopes. It can happen on transaction scopes, although it would make a lot less sense on a transaction scope PC, right? That would be if you wanted to control when it joined. 3 minutes. I also wanted time for feedback. I guess I'm not doing well there either. So if there's a new transaction, then you will not be joined to that transaction unless you explicitly, again, say join transaction. So it's a one-shot deal. Each time you want to be part of the transaction, you say join transaction. Normally, you'll only say it once. That's when you're done. You have all the changes stored up in your PC, and then you want them to be saved. And here's the example. I've got a shopping cart. This is a traditional stateful example. I've got a cart. I specify, and again, extended is the type of persistence context that is going to make the most sense for this. All right? Because transaction scope doesn't make a whole lot of sense. I mean, there are a couple of cases, but generally this is what you'll want to use it for in a stateful session bean. So you'll have your entity manager, and then, in some initialization here, you'll create a cart. You'll add some item to the cart, and you're persisting the item. You're adding it to the cart. It's just getting stored away. At some point, the user says, yeah, I'm done all my shopping. I want to buy. Buy now. And so complete purchase gets called, and I say, okay, join transaction. And all my changes in the persistence context get foisted into the transaction, synchronized, and at commit time, they all get written out. So that's the use case that unsynchronized persistence contexts meet. There could be a couple of other cases, but it's essentially explicit control over the enlistment of your changes. Now, there are some problems. One is the cache. If you're doing this and there's transactions going on, meanwhile, the longer this happens, the more your cache could be out of date, because your persistence context is acting as a cache. So optimistic lock exceptions could happen. You can't use pessimistic locks because you can't, right? There's not transactional. You missed that boat. The second one is the data source. What happens if you have a JTA data source, but you're not enlisting in the transaction? You're reading things from the database, potentially, that are transactional and not committed. For the existing JTA transaction, things are being changed and written out and committed. You're not committing anything, but other things might be. other people who are using the JTA transaction might be writing stuff out, other resources. If you're reading from that same transactional connection, but not writing out, you could see some uncommitted changes. What if the transaction rolls back? And you didn't know about it. You don't care because you're not synchronized. You could be using uncommitted data in your PC. So that's why we say specify a non-JTA data source as well if you're using this feature. And lastly, well, other things are committing. You can't roll them back. If you have multiple commits happening, then you say, oh, you know what? I don't really want to do this anyway. I'm going to throw away my cart. Well, other things that may have committed in those JTA transactions got committed, right? You can't uncommit them. So depending on what happened, let's say it was a message queue. You started a transaction and sent a message to some other back-end system that said, oh, guess what? Google wants to know that you're buying this, right? And that message got committed and sent off, and Google thinks you bought it. Right? It doesn't know because it got committed. So those are some issues to think about and be aware of. And that's all I promised, because schema generation. Oops. I did want to ask what your current pain points are. And I also, being that I'm working on the next version of the Pro JPA book, I want to know what pieces got missed there. So if you have any suggestions, please let me know about that. And feature requests for 2.2. Anything else that you might have? We don't have time now, but I'll be outside if you want to talk to me and give me your input. Thanks a lot for coming, guys. Enjoy the conference.